Y. I heard that.
Andrew, what are you doing?
Okay,
Why'd you put
ladies and gentlemen.
twice? Did you mean to put adjacent?
Yeah. I didn't want to do that twice. Thank you.
That's when you say you're welcome. Oh, you're welcome.
Okay, ladies and gentlemen, trigonometry is what? Study of triangles. That's the simple definition. Study of triangles. Now, starting out, we're going to work with right triangles to begin with. They are always correct. I know I have a right triangle because of this little box. A lot of this stuff will be a review that you've had in geometry last year. Now, a lot of you also, I believe that geometry makes this stuff more difficult than what it is. That's my opinion. I think it goes a lot easier by using trigonometry. Terms, hypotenuse. Hypotenuse is always what?
Opposite.
Longest length, that's number one. Number two,
Opposite of the right.
opposite the right angle. So if I'm standing here at the right angle and I'm looking away, that's always the hypotenuse. The hypotenuse never changes. Once you're locked in and you're known as the hypotenuse, you can't change your name at all. Now, when we talk about opposite and adjacent, they are somewhat interchangeable, depending on your perspective, where you're standing. If I'm standing at angle B, if I'm standing right here, this is the hypotenuse no matter what. Doesn't matter if I'm standing here or here. But, which side is opposite B? B. B is what? Adjacent to A. So depending on where we stand, opposite and adjacent are kind of interchangeable. Adjacent means that you share, or you're next to. You share a leg. If we have two angles side by side, Dennis, come here. Make an angle like this. Okay? Right now we are adjacent. We share a leg. These are called legs.
Dylan, start recording this.
Arms, okay?
No,
Now,
that's not gonna happen.
so we have to know these three words because they are the foundation of your 6 trig functions. Now, 3 of them you've done before.
Yeah.
Sine, cosine,
Colin, good job.
and
Yeah, no
tangent.
problem.
What's that?
What about tan -1?
That's inverse, and that's if you're working backwards. We'll show you that here. Now, sine, you will see sin, you'll see cos, and you'll see tan. Now, I don't know if you know this, but they have brothers and sisters. I call them brother-sister. Sine and cosecant are considered brother-sister, or sister-brother. I always say brother and sister because it doesn't matter which one's which. You will see the abbreviation CSC for cosecant. Cosine's brother-sister is secant, and the abbreviation will be SEC. Great conference, probably one of the best, or the toughest football conferences in the nation. And cotangent is the brother-sister. Now, when I say brother-sister, these are reciprocals of each other. So if I tell you the sine of something is 3/5, what's the cosecant?
3/5.
5/3. So if I have 3/5, I know that the cosecant is 5/3. All I did was reciprocate them. And we will use those a lot. We'll go back and forth quite a bit. In fact, I'll ask you to give me the 6. These are called the 6 trig functions. Okay? Now, how did you remember sine, cosine, tangent?
SOHCAHTOA.
SOHCAHTOA. SOHCAHTOA. So, ha. Now, I don't know if you know that, but that was originated from my family. Yes. I have a great-great-great-great-great-great-great-grandfather, Culiano. And things happen to your name over time and generations. You know, Culiano was in Italy. And then my great-great-great-great-great-grandfather came over here to the United States, and when he walked in, he was going, Culiano, Culiano. And they were going, what? What? He goes, Culi. Oh, Culi, got it. And that's what we've locked in since. It's just kind of transitioned. I don't know why. But this is a true story. And this is where Sokoto was developed. Not a lot of people know this. In fact, you're pretty fortunate. We're going to get on tape, so it'll be fact. Yes. My great-great-great-great-great-great-grandfather Culiano was walking home from work one day, and he was walking on the brick path, and he was looking up, and he saw my great-great-great-great-great-great-great-great-grandmother Culiano. She was putting apple pie, and she made the best apple pies from what I understand. And she was setting it out on the windowsill and letting it cool off for my great-great-great-great-grandfather Culiano when he got home. Yeah, I mean, well, you know, I put parentheses with some number up here. And as he was walking, he was looking up and admiring the beauty of his wife and looking forward to that pie. He hit a curb with his toe. And he's like, oh, and he's jumping around. I can't really jump around right now to imitate him, but this is the story that I was told. He's grabbing his toe, and my grandmother, oh my gosh, what's the matter you? And he's jumping around. He goes, oh, my toe. And she yells down, you come up here, we so katoa. And it just punched him in the face. Wow. So, Kato, that will help me remember the 6 trig functions. My grandpa he kind of thought a little differently. So then he passed it on from generation to generation, and now, ladies and gentlemen, for the low, low price of showing up today, you also know where this originated. What does it mean? Sine, opposite, over hypotenuse. So what does that mean that cosecant is? Hypotenuse over apo. Ka! ADJ over HYP.
Yeah.
Hype over extra. Bless you. And tangent. Up. You down with?
To get 205 for 6-ish.
And cotangent would obviously be. And I never have anybody memorize these 3. Never. I just have you know that what's brother, sister. These 2 are easy because they both have the word tangent in them. It's like brother and sister that are Robert and Roberta. Or Aaron and Aaron, spelled differently. That's Aaron and Erin. So, adjacent over hypotenuse. So, ladies and gentlemen, let's take, for example, a right triangle. Anybody know if this is 3 and this is 4, what this has to be? 5. If you're not sure, what do you use? Pythagorean. Take your a squared and b squared. Add them together. A and b are your legs. C is always the hypotenuse. You should know the 3, 4, 5, which would be the same as 6, 8, 10, 9, 12, 15, and so on. The other one that's pretty popular is 5, 12, and 13. I think there's a 17, 18, 5, something. But those are probably the 2 most popular right triangles. So let's say that I am using, and you'll see this symbol a lot. And that symbol for all you Greek people. Anybody in here Greek? I had a Greek student last semester, Anna. Nice girl. She lived in Greece for a long, long time. That's theta. Theta. I don't know why, but it is. So, what that's telling me is that's the location that you are using. That's the location that you are standing at. I would like the 6 trig functions for theta. So I would say, okay, that's not too bad. Sine, cosine, tan. I always write them brother, sister next. I don't know if this is the right order or the wrong order, but it's the order. So real simply, I go to my location. Sine is what? Opposite. So which one's the opposite?
4.
4, what's the hypotenuse? Done. Cosine. 3 over 5. Adjacent over hypotenuse. Tangent. Opposite over adjacent. How do I do the rest? Flip them. These flip. 3/4, 5/3, and 5/4. Yeah. Yeah. Until I do something a little unique, which I'm known to do.
That's right.
64 and 25.
You look at your teacher.
80.
Especially at college.
There's your hypotenuse.
I just wouldn't. I'd drop out. Like legitimately.
How about
work at McDonald's for the
takes 5 seconds. Sine would be what? 8 over square root of 89.
6.
Oh, our math geek says no radical but. So he would go 8, what? Square root 89 over 89. You're going to do this 1,000 times. Oh, quit your whining, my gosh. As we know it, it's the end of the world as we know it, and I feel fine. Oops, I forgot. Sorry. No radical buts.
Someone
It's
hear
gross.
I didn't get it.
Now, well, I got this. My butt gets dry, so I got to put a Band-Aid. I was just pointing that out. I know, I went right for the jugular. Get a picture of Harding's face. Get a picture of Harding's face. No, it's not. Jugular.
No, it's not. It doesn't have the same effect anymore.
You're so good.
She is. I know, and we got it on video.
Mm-hmm.
No, I didn't.
Yeah. Got it.
All right,
He
now,
definitely did.
here is something. This is one thing you have to memorize. Sine, SOHCAHTOA, and this is the other one. Special triangles. They are very, very special. McCoy, this is for you. You will be in charge of those boys that don't write anything there. Okay?
It's back at
Because
208.
you're a non-writer also.
It's back at 208.
All right? Christensen, Tammy's
Yeah.
going to call me and I'm going to say, well, he didn't write it down. I don't know. Ka, I'm giving you a chance to show your mom what's going on in math instead of talking about it. But you choose, I'm going to talk about it. I disagree. Now, there are two special triangles that we will spend a ton of time on. You will draw this triangle right here 100 billion times.
Oh,
30 degrees. If this is 30 degrees, what's this? So this is called a 30,
69.
60, 90 triangle. Now, last year you used X and X radical 3 and all that. We aren't going to put any letters with this. Very few letters with trig. The other one that you're going to use is a Anybody want to guess?
45, 45, 90.
45, 45, 90. Anybody know the dimensions of a 30, 60, 90 triangle? They're easy as 1, 2, 3. 1, 2, and 3. Very good. Where do you think the 1, the 2, and the 3 are going? Most people say 3 would go on the hypotenuse, but I'm going to tell you one of them's a radical. So I'll just show you. It'd be easier, wouldn't it?
Isn't it like 2 squares?
So it's S, 2S, and S squared.
30, 60, 90 has 1, 2, 3 in it. 3 is next to 3. So 1, where does that come from? Pythagorean. 1 squared plus radical 3 squared would equal 2 squared. It works. Anybody know the dimensions? 45, 45 means that they're going to be the same. 1, 1, square root 2. That needs to be memorized. I will see you in the halls, and I will ask you in front of a whole group of people what are the dimensions of a 30, 60, 90 triangle. First of all, you're going to go, and then you're going to have to think. You're going to make sound while you're thinking. That's what all kids do. After 30 seconds, then I make a big scene.
Like how?
I don't know. Every situation will be different. I'll have a video camera with me also in case, so that we can put it on YouTube, in case it's really good embarrassing moments. Joes, I don't worry about you, because you will quietly say, dimensions of a 30, 60, 90 triangle are 1, square root 3, 2. And I'll go, great job, and I'll walk away. Simple.
I kind of want to come by and not answer just to see you freak out.
I won't freak out. I'm really quiet and shy. What is the sign? What is the sign of 30 degrees? Everybody say it. Sign of 30 degrees is? Well, I go to the 30-degree angle. Sign is what?
1 over 2.
Opposite over hypotenuse. Opposite over hypotenuse. So the sign of 30 degrees, everybody. 1/2. 1/2. 1/2. 1/2. 1/2. 1/2. I'm going to hold off on this.
We're good, Andrew.
Make sure I get through it.
Take your brain's attention. Watch this.
Brandon.
Psst, Brandon. Brandon.
We don't approve of that language. What if your mom sees this?
I would like for you to solve this triangle.
He's just genuinely offended at the fact that you pointed that.
Now, to solve this triangle, anybody know what a proportion is?
Yeah.
What if you like
Two fractions that are equal to each other. How do you solve a proportion?
How do you what?
Solve a proportion.
You
Cross multiply.
Oh.
Exactly. Angle B is probably the easiest thing to find. What is the sum of all three angles of a triangle?
180.
180. But in this case, I already have 90 of it, so I only have to find this angle and this angle. I have to add up to 90 degrees. So 55 degrees is pretty easy to get. Any problems with that?
No.
Okay? Which side do you want to? Which side is this? A or C?
A.
This is A. A. Big A is an angle. Small a is a side. So we'll call this A, and this will be C. Hypotenuse is always C. I don't know why. It's the way it is. Some things we learn to accept. Just like my story about SOHCAHTOA. Just accept it. Let's say you want to find A first. I know 35 degrees. I need to find A, and I have 7. How does 7 relate to 35 degrees? It's adjacent. A is what? Opposite. So I'm talking about opposite and adjacent. Which trig function is that? Tangent. So, would you agree that if I take the tangent of 35 degrees, it should be equal to, the tangent of this angle is equal to the opposite over adjacent.
What?
Yes.
How do you solve it?
Cross multiply.
7 times tangent 35, what do you get? Oh, make sure you pull out your calculator and try it, because some of you will have your calculator in radians.
Oh, we need it in degrees, dude. Dude, you know stuff how we did this last year?
Yeah.
And my calculator was in radian, not degree.
Tangents,
For
it's
what?
on your calc.
My calculator was in degree, or radiant,
Yeah,
not degree.
3.3.
The whole year?
You took 7
Yeah.
times
Really?
tangent
I bet
35.
you Mr. Tom didn't tell you anything about it.
She eventually did. My contract's over.
Contract's over.
I'm on strike.
So, 7 times tangent 35. Did you have parentheses? When you type in tangent 35, it'll show up like this. It'll say tangent, and then you'll have a parenthesis. You gotta put a parenthesis around it, close it up.
I did it. I got
4 points?
4.9014527.
What am I doing?
Now, how do you find C? You can use Pythagorean, a squared, b squared, or how does, you can also use, let me see your calc.
Wait, so how did he get 4.9? You used what?
SOHCAHTOA.
See yours
No,
is
like
in
which one did
radians.
you use?
SOHCAHTOA.
No, which
Oh, which one did you use? Use TOA.
I don't know how to change it.
TOA.
Go to mode on your calculator, hit mode,
Should I still be
Opposite
recording?
division.
and then go to